What's up everyone, Patrick here, welcome back. Moving on to the next video, what we got to do is we got to take each of these trinomials here. We have to verify that each of them are a perfect square trinomial, and then we have to factor them. So a couple of things I want to mention, and I mentioned this briefly in the overview video for a perfect square trinomial as well, is there's multiple ways to verify that it's a perfect square trinomial. In fact, if you just factor it, and then you end up with the format where you just have one factor to the power of 2, then it verifies that it's a perfect square trinomial. But there's also another way to verify it, and that's through that formula that I showed before. So just in case your textbook or your teacher requires you to use that formula, I'll verify each of these with that formula first, but then I'll also factor it. So if your teacher's not going through that formula, feel free to ignore that portion and just focus on the factoring portion. And the formula, more specifically, that I'm talking about, just to bring it back from the overview video, was a squared plus 2ab plus b squared, and that's equal to a plus b squared, like that. And remember, this could also be a minus, so instead of putting a second formula here and changing this to a minus, I'll just actually put this could be plus or minus, this middle portion, and then that would affect this. That would make this either plus or minus, right? So if this is positive here, then you're going to end up with a plus b squared, and then if it's negative, you're going to end up with a minus b squared. So if we can show that each of these are in this format over here, then we verify that it's a perfect square trinomial with the formula. But again, I'm also going to factor it with decomposition to show that we get the same solution whichever way we do it. Now, another thing I want to mention is that notice all of these, they have an a value of 1. In the next video, we'll do a couple where the a value won't be 1. When you're factoring, remember, you always want to check, can you take out a greatest common factor initially? In these particular case here, because we are verifying that they're perfect square trinomials, there's not going to be any greatest common factor to take out. But remember that when you're working through factoring any expression, you always want to check for that initially. Okay, so let's start off with the first one. So we got x squared plus 14x plus 49. So what we want to do, we want to try to take this and see if we could rewrite it in this format. Now, notice we're going to be dealing with the positive case because we have a plus right here. And I mentioned this in the overview video. What I like to do is try to take the ends and match them up. So here, notice that both of these are in the same format already, right? We got the a squared, then we have the x squared. So it's easy to tell that the a value in this case is going to be x, and it's actually going to be the a value in all of these. In part E, it's going to be a little bit different, but up to part D, basically the a value, the a squared, it's always going to be this x squared in front. What's going to change is this b squared value. So notice we have a plus 49 here, so we can rewrite this as plus 7 to the power of 2, like that. And so notice we have b squared, 7 squared, so we could tell that the b value is 7. And so now what we want to do is we have plus 2ab in the middle, so we'd have plus 2 times the a value of x times the b value of 7. And notice that we have 2 times x times 7, which gives us 14x indeed. Right? And so because we were able to take this trinomial, rewrite it in this format as we did over here, where the a value is x, the b value is 7, that verifies that it's a perfect square trinomial. And if you take these and you plug them here, because we're dealing with the positive, we would do a plus b squared, so it would be x plus 7 squared, like that. Okay, so that's if you do it the formula. Again, if you're not going through this formula, if your teacher is not going through this formula, feel free to ignore this portion and just go straight into factoring. Now, if we do go into factoring, we would do it with decomposition. Remember, first thing we always check, greatest common factor. Can't take anything out in this case, so A value is 1, the B value is 14, the C value is 49. The AC value is 49 times 1, which is 49. Find two numbers that multiply to 49 and add up to that B value of 14. And notice it's 7 and 7, right? And I mentioned with a perfect square trinomial, these numbers are always going to be the same. So then what we could do, we could decompose that middle portion. We can factor out an x from these two. We could factor out a 7 from these. Then we could take out an x plus 7. And what are we left with? X plus 7 as expected, which would give us x plus 7 squared. Okay, so whichever way you do it, whether with the formula or with decomposition, you get that same value. Now let's move on to part B. So with part B, we have, let's keep the formula up there. We got x squared plus 22x plus 121. So first thing, let's rewrite the n's in a squared and b squared format. So this is already in that a squared format. We could tell the a value is x. Here, this 121, notice we could rewrite that as 11 squared. So notice that the b value is 11, and then we have plus 2 times the a value, which is x, times the b value, which is 11. Notice 2 times x times 11 does indeed give us 22x. So because we were able to take this, rewrite in this format, we showed that it's a perfect square trinomial. We verified it the formula way. And then if we want to get this side, if we want to factor it quickly, basically it would be a plus b, because we're dealing with a positive here, so it would be x plus 11 squared, like that. Okay, if we do a decomposition, then notice the a value is 1, the b value is 22, the c value is 121, so the AC value is 1 times 121, which is 121. The AC value and the c value is always going to be the same in this case because the a value we're dealing with is 1, but that's not always going to be, as we've seen in previous examples. So, 22. Two numbers that multiply to 121 add up to 22, 11. Okay, so we end up with x squared plus 11x plus 11x plus 121. Factor out an x, factor out an 11. Take out the x plus 11. What are we left with? X plus 11, right? And so whichever way we do it, whether with the formula or with decomposition, we end up with the same solution. Moving on to the next one, notice that in this case, what we're going to have is a negative in the middle. So we got x squared minus 8x plus 16. So again, let's work with the ends. The 16 we can rewrite as 4 to the power 2. So notice the a value is x. The b value is 4. So because this is negative, we're dealing with the part of the formula where it's a squared minus 2ab plus b squared. So we'd have minus 2 times the a value of x times the b value of 4. Notice negative 2x times 4 does indeed give us negative 8x. Took this, rewrote it in this format, verified that it's a perfect square trinomial. This side, the right side, is going to be a minus b because we're dealing with the negative case. So x minus 4 squared, like that. Okay, so that's with the formula. If we do decomposition, I'm going to just skip a few steps here. Hopefully, once you list the a, b, and c values, the AC value is going to be 1 times 16. So we've got to find two numbers that multiply to 16, add up to the b value of negative 8. Notice in this case, it's going to be negative 4, negative 4, negative 4, negative 4. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 is negative 8. Decompose. Take out an x. take out a negative 4 here. And then we could take out an x minus 4. What are we left with? That same bracket, x minus 4. So we end up with x minus 4 squared, whichever way we do it, whether with decomposition or with that formula. Then moving on to part D. So same thing at this point. It's just sort of following a pattern. So I'm actually going to just rewrite writing the trinomial just below the formula. So again, let's rewrite it in this format. So we'll have x squared, the minus 2ab, let's rewrite that in a sec. And then the b squared, that's going to be 9 squared in this case, right? The square root of 81 is 9. So the a value is x, the b value is 9. And then we have minus 2 times the a value of x times the b value of 9. Notice when we multiply these, we do indeed end up with negative 18x. And because it's a negative, it would be the a minus b case, so this would factor into x minus 9 squared, like that. Okay, so x minus 9 squared, whether you use the formula, if you want to do decomposition, what are two numbers that multiply to the AC value 1 times 81 and add up to that b value of negative 18? That's going to be negative 9, negative 9, negative 9, negative 9. And so we end up with x squared minus 9x minus 9x plus 81. Take out an x, take out a negative 9. Then we could take out an x minus 9 from both, and we're left with x minus 9. Okay, so whichever way you do it, you get x minus 9 squared. Now this last one, it's in a bit of a different format, but that's okay. So we end up here having 25 minus 10x plus x squared, like that. So it's a little bit rearranged. Now if you want, you can bring this in front, okay? So like this and this are actually the same thing. And just to kind of go ahead, basically this would factor, if you follow the same steps, x minus 5 squared. This, when we factor it, which I'm about to do, we're going to end up with 5 minus x squared. And I'm going to show you at the end why both of these are actually the same thing. Right, I'll do a little bit of algebra to get from one to the other, just to show you, just so you're not confused. But basically, both of these are the same. So you could rewrite it like this. I'm going to just work with this format, how it's given, just in case maybe your teacher or textbook goes through it in keeping this format here. So exact same thing. What we want to do, we want to try to rewrite this as a squared, so we can rewrite this as 5 squared, and then this is going to be x squared. So notice that in this case, the a value is 5, the b value is x. And then we have a minus here, so we're dealing with the minus 2ab case. So we'll have minus 2 times the a value of 5 times the b value of x. Notice when we multiply these, we do indeed end up with negative 10x. So because we were able to take this and rewrite it in this format, we verified it's a perfect square trinomial. And because we're dealing with the negative case, it's going to be a minus b 5 minus x squared, like that. Now, if you did want to do this with decomposition, see, this is where it gets a little weird, because with decomposition, you would actually rearrange it. Right, so you'd have x squared minus 10x plus 25. The AC value would be 25. The b value would be negative 10. So the two numbers would be negative 5 and negative 5. So then you would decompose this. And then you'd factor by grouping. And you could take this out. And you're left with that. So you end up with x minus 5 squared. So let me actually write both of these here. X minus 5 squared. And here we got 5 minus x squared when we use the formula. But both of these are the same. That means both of these have to be the same. Again, I'm going to show you in a sec why. Now, if you wanted to do decomposition in this format, I think you can. It would just be a little bit more weird. Okay, so from like these two, you could take out a 5. And from these two, you could take out a negative x. And then you could take out a 5 minus x. And you're left with 5 minus x. So you end up with 5 minus x squared, like that. So you can do it like that, but usually, again, with decomposition, we rearrange it in a way where we can have an a value, a b value, a c value. I guess in this case, you can just say the a value is 25, the b value is 1. It's just a little bit weird to maybe get your head around because we've been used to always putting the leading expression in front and letting that be the a value, getting the leading coefficient from there. Okay, so whichever way you do it, you get one of these two answers. Now, both of these are actually the same, so let me show you. Now, when you just look at them separately, so like x minus 5 is not equal to 5 minus x. Okay, these two are not equal, but when you square them, then they are equal. Okay, so like notice if we plug in like a 2 for x, if we have 2 minus 5, that would give us negative 3. Then if we have 5 minus 2, that would give us positive 3. So over here, they're not the same. But notice here, we would have negative 3 to the power 2, which would give us positive 9. And here we'd have 3 to the power 2, which would also give us positive 9. And the reason how we could show this algebraically is if we take like this 5 minus x squared, what we can do is within this bracket, let me actually put a square bracket just because I'm going to be introducing more brackets. What we can do is we can actually take out a negative 1 from this. If we factor out a negative 1, this would change into negative 5 plus x, right? Or we can rewrite this as x minus 5. Negative 5 plus x or x minus 5, those are the same thing. And we still have that squared on the outside. Okay, so this 5 minus x and these two brackets multiplied are the exact same thing. And now whenever you're multiplying two things, you have an exponent on the outside. You can rewrite this. We could take both things to that exponent. Negative 1 to the power of 2 is positive 1, so we end up with x minus 5 squared. So we just showed through all of this, we didn't add anything. We just kept this expression, rewrote it, used exponent rules. We end up showing that this and this are the exact same thing, right? So whichever one you get there, it is correct. It's just sometimes maybe textbooks will show it this way, right? If they have it in this format, if you get this, you didn't do it wrong. It's just a different format, right? So that's how we work with perfect square trinomials, verifying them, then factoring them. In the next video, we'll do a bunch of other examples where this a value is not 1.